In this video, we're going to have a look at how we can graph sine and cosine functions that have undergone horizontal translations. So consider in the previous videos, you would have seen that we could do horizontal and vertical dilations by writing something like y equals sine or a sine, and then in the parentheses n times t. So in this video, we're moving to a different form and we're going to say y equals a times sine, then in parentheses n, and then we're going to have t plus or minus a new variable called epsilon. And in this form, our a here still represents our amplitude dilation, and our n represents our period dilation. And finally, our epsilon. So our epsilon here, this is the new variable we're dealing with. This will be the horizontal translation. So translation as in we slide our function left and right on the x or this horizontal axis, in this case the t-axis. Now we can have positive and negative epsilon, and the positive and negativity of epsilon represents whether we shift our graph left or right. So for positive epsilon, we shift everything to the left, and for negative epsilon, we do the opposite. We shift to the right. Perfect. Now going down, we'll have a look at some examples. So going down here, we've got two examples. So we're going to have a look at example A today. So y equals 3 sine 2 times t minus pi on 4. And we want to do it over a domain. We want to graph this over a domain of pi over 4 t and 5 pi over 4. Alright, so the way in which we're going to attempt this question is, firstly, we're going to identify all of our variables. Then we're going to identify, or we're going to calculate what our period will be, in this case of the period of this sine function. Then we're going to try and graph. So we'll draw the rough outline of one period of this sine function, and after that we'll mark where the sine function begins on this particular graph. So it's translation, and then finally we'll draw in our y-axis and mark our amplitude. So jumping in it, the first thing we need to do is, as I said, figure out the period. So to do the period, we're going to ignore the epsilon altogether for now. So we're simply going to say y equals sine 3 sine 2 t. So notice that I booted the epsilon out of this equation just for now. And the next thing I want to do is I want to find the period. So the period itself is defined by the n. So period in this case is going to be 2 pi divided by n, and notice that n is 2. So we're going to get 2 pi divided by 2, and therefore our period for this particular function is simply going to be pi. Perfect. Now the second part is we have to identify the shift. So in this case, our shift, or our translation, is going to be epsilon, where epsilon equals negative pi over 4. So what we're going to expect is a shift to the right by pi on 4. So if I grab my pen, I'm going to mark here, I'll say pi over 4. So this point here is where we should expect our sine wave to begin. And alright, so if I draw a sine wave on this particular set of axes, or this y-axis, what I'm going to get is this. Now my next step is I need to know where one full cycle of this sine wave is. So I can calculate that by saying, so the point at which one cycle occurs, so this point. So this point here, we can calculate it by saying pi over 4 plus pi being that's our period down here. And that's going to equal out to be 5 pi over 4. So I can write five pi over 4. And one more piece of information that I'll use to annotate this particular graph is I'll find this point over here. So this point is going to be the midpoint between the start and the end. And just looking at that, pi on 4 and 5 pi on 4, midpoint of that is 3 pi over 4. Excellent. Now, the next step into finishing this off is I need to annotate the y-axis. So if this is pi on 4, and this is 3 pi on 4, and this is 5 pi on 4, I'm going to say that the y-axis is roughly here. And this will be y. And this point over here, so dealing with the amplitude dilation, up here, this is going to be positive 3 on the y-axis, and this is going to be negative 3 on the y-axis. Alright, perfect. So now that I've sketched one period of the sine function, or this dilated sine function on these axes, I'm going to go back and I'm going to have a look at the specified domain in the question. And in this case, it said it wanted a domain, or wanted us to sketch this graph between pi on 4 and 5 pi on 4. And lo and behold, the period itself and the start point is actually pi on 4 and 5 pi on 4. So to finish it off, what I'll do is I'll simply get my pen and I'll draw the little circles, filled in circles on points pi on 4 and 5 pi on 4. And what that represents is that this graph starts at pi on 4, so it touches the point, and then finishes at point 5 pi on 4 on the t-axis. And then secondly, we can see up here that it's got a maximum value of positive 3 and a minimum value of negative 3. So this is you could take this as a basic example of how we could graph some dilated sine and cosine functions that have also undergone a horizontal translation. In the next video, I'll have a go at doing this function here.